This is part 9 of the sampler Loopstation tutorial. So this time we are multi-tracking. We're trying to build more than one track. We have successfully built one track. And we did the supercladder part of the multi-track, or some of the supercladder part. Now what we need to do is build in the processing part, which might take a little bit longer than the supercladder part. So we'll maybe take a few videos to do this. Okay, so right now what we need to do is we're just going to kind of go through our processing code as it stands. This is one track, just like that. Okay, so why don't we try producing more than one track? All right. So what we have is we have something that's about 1,150, this track background. All right. But what we'll do is we'll again use these for loops. They're so useful. We'll go ahead and expand that to as many tracks as we'd like. And we can do some, a lot like what we did in supercladder with these calculations here. What we can do is we can maybe do some calculations based on our track height and width, something like that. Okay. So I have this width and height there, but maybe before this, instead of that, I'll have, I'll start up here, and I'll have an integer, and I'll call it number of tracks, NUMTRX, and I'll go ahead and just set that there. Okay, and then maybe everything else will be based on that. So maybe we can have an int tr track height, and we'll make that 150, and trw track width. Well, I guess we're just using width there. If we need a track width, we can do it later. So we have a int w and int h. So we'll move those up here, and then we'll initialize them later. So we'll say int w and h. Okay. And we're going to get rid of these. Actually, int w might need to, we'll just assign 1,000, since the tracks are going to take up at least for now, the entire width of the canvas. We'll just assign that width to 1,000, and we'll just have an int h. Okay, and then we'll just calculate that in our setup. We'll do it after all this business, after the OSC business. We'll say h is equal to the number of tracks times the track height, right? So NUMTRX multiplied by TRH. Is that right? Yeah. Okay. All right. Now the only issue there is we have to hard code, and I'm not sure why they did this, but the new version of processing does not allow us to use variables here. So we just have to actually do the calculations manually anyways. But at least we have it here. So, you know, our width is going to be 1,000, and that's going to be 150 times 8, which is, what is that, 1,200, is it? So maybe we shouldn't be quite that high. Maybe if we just stuck to maybe 120. Let's see what that might be too high. So 120 times 8, 800, 960. Is that much better? Is that right? 8 and then 20, yeah. 960. That sounds a little bit better. Okay. So let's just see how that looks for now. Oops. TRHT. Okay. So that's going to be our canvas there. All right. Okay. So that looks okay. So now we've done some calculations, and what we'll have is let's see now. Do we need an extra variable though? No, we have several. Right, okay. So we'll have several tracks, the background. So let's take care of this track background here. Fill and rect, what we're going to do is you can use your for loop to draw several rectangles, and we'll use the I of the for loop to increment based on some of those things we just calculated. So we'll say for, set that up, int I equals 0. I is less than, we'll say num trx, and I plus plus. Okay. All right. And then eventually we want to get something that looks like this rectangle. So at least for now, they'll all start at 0, 0. And then the width is going to be, we'll just make it the W, the width. And that might change later. So it's really the height we just need to increment. I'm sorry, we do need to increment too. This is the Y, right, where it starts. So if I is 0 the first time, we can do I times TRHT, the track height. And let's just test that if that works. So when I is 0 the first time through, it's going to be at 0, 0, Y 0. The second time through, I is 1, so it's going to be at 0, 1 times the track height, which was 120, I guess we established. Yeah, 120. Second time through 2, it'll be at 0, 2 times 120, or 240. So that seems to work. And actually, this can just be track height, because that doesn't change. It's always the same. Yeah. And so this will draw us that many number of tracks, that many rectangles. So let's give that a shot. Okay, and then it looks good. What we probably should do is alternate. I'm thinking my other one. Let me just see what color I alternate with. All right, black. Okay, that's pretty good. So why don't we do that? Why don't we alternate between black and this blue, this dark blue color? So in order to do that, we do have to pop I into this for loop. So I'm going to cut that, pop that in there. And we'll just use an if statement to alternate between the two different fills. Okay. And since I'm just doing one command, I can use that shortcut if statement that doesn't use the curly brackets, but just puts everything on one line. So we'll make the dark blue the second time. So we'll say if I so I think is there an even? Is even? We might have to do it manually. So if how do we tell the odds? There's no processing command in SuperCollider. There's just a is even. There's a command, which is candy. But I think this one we'll just have to use the modulo. So we'll say if I modulo 2 equals 0. Okay, so that's one way of doing it. So that means that, you know, whenever it's even, so 4, 6, there'll be no remainder. 2 will go into, 2 will always go into it with a 0 remainder. So that means it's even. The fill's going to be this dark blue, and else we can just say else. So that means when it's not even, so it's odd, fill, it's just going to be black 2, 0. Okay, let's give that a try. So we can see our tracks. They're differentiated then. There it is. So we have a blue track and then a black track, etc., etc. So that's how we make, multiple tracks. And the nice thing about it is then you can just, I really do wish we can change the size. That's the one sort of glitch there. We'll have to do that manually every time. But I'm sure there must be a way, but They've changed the processing thing, so you can't use variables there. But you know, if you can change the number of tracks, say to 4, and then I guess you'll make this, you know, 120 times 4. So it's 480. You know, and it'll draw the 4 tracks automatically. So apart from the slight hiccup there of the size, you know, you can just change the number of tracks as you go. Okay, so let's put that back anyways. Okay, so let's just keep working down the graphics, and then we'll have to do a number of things to change the way processing talks to SuperCollider as well. So we're going to follow the same sort of business. You know, this just as a review, these just have 2 different track colors. This color, okay, and then it's drawing, you know, number of tracks times rectangles. Okay. We'll deal with this later. The update waveform, we are going to have to do that, and we'll deal with this later. Okay, but let's deal with the beat grid. So we have these lines here, these 4 lines. Okay, so we can also make these. Let's first start by just making this, even the single track, a for loop. Okay, so we'll need some kind of you know, number of measures. We'll need some variables, so we'll have int, and I just want to be consistent with what I've done before. Int, do I have total beats, beats per measure, total measures? Okay, and I don't know what the rest of this is, but we'll figure it out. Okay, so we have, maybe I'll figure out a better way to do it even. Well, anyways, we have measures. We'll have num mes, and we'll say 4. Okay, so let's just start there and see where that gets us. So if we want to do number of measures in 4, we're going to create a line. Right, so we're going to create a for loop. Int I equals 0. I is less than num mes I plus plus. And actually, we might be able to just fit this all in one line again. Do a little shortcut, and it will be line. And remember, x1, y1, x2, y2. So x1 will always be, we're going to move that over. So it will be, so this is actually just for one, huh? This for loop is just for one track, right? But it's going to draw all the measure lines across. So it's the only thing that changes is the x-axis. Okay, so for now, I'm going to fill in 0, and then we're going to change that later, the y later when we do it. Okay, so it's going to be, anyways, the x is the one that changes. So it's going to be I times, right, so we have to actually solve for the how many pixels is in a measure. So let's go ahead and do that. So if the number of measures is 4 and the width is 1,000, we'll just have to have another variable here that's called, I guess it needs to be an integer as well. We'll just keep these integers for now. Well, we have to round it somehow. Well, let's make it a float, okay? And it will be pix per measure. Something like that, pix per measure. And we'll do a little calculation here. So pixels per measure is equal to pixels per measure, and we'll do that. You usually do your calculations if you're setting up a variable and it's based on some kind of calculation. That's usually done in setup. So pixels per measure is going to be equal to the width, the total width. Again, that might change up maybe track width. We'll have to update that when we get to it. Divided by the num measures, MES, right? And that's a float number because in division you might end up with a float. And let's just leave it at that. I think it's going to be accurate if I just leave it a float. I think that's going to work. And so where were we? Here we're going to do line times. Right, so if we want to draw a line for every measure across the x, we're going to have to update x. So x1 and x2 will be the same since it's just a perfectly vertical line. So I times pix per measure, MES. Yeah. So let's test it in our minds. 0. It's 0, so it starts at 0x. And then 1, it'll start at pixels per measure, whatever that is. So 1,000 divided by 4, 250, right? So it should work. So that's our x1 and our x. So let's put a couple commas in because that's also our x2. So it's a vertical line. And then the y's are going to be, for now, as a placeholder, let's put in 0 and the track height. But we're gonna increment that with the next loop. Okay. And so hopefully it does this. It does exactly this. And let's just delete those for now. And let's see what happens. Okay. Yeah, so it draws these lines across, which is nice. Okay. Now, what we need to do now is also draw for every track that we have. So what we'll do then is so that's this is, let's see. This is the, how do we call this? Draw measure lines. For one track. Okay. It's just, never mind my dog. Dust, come here. Down. Good girl. Okay. Apparently there's some home invasion going on. All right. Draw measure lines for one track, and then now we're going to do it for each track. We're going to do another for loop. Now, just to be aware, so since we use this for loop with the I, we're going to have to use a different variable name, right? So if we use I in this for loop, it's going to get confused to which I is right. So oftentimes I use J. So I'll just say for int J equals 0. And this is now for each track, right? So we're going to do J is less than num tracks, and then J++. And this one won't fit on one line, so we'll just go ahead and do that. Or it might, but that's okay. We'll just go ahead and do that. And then, so what do we want to do? Well, we want to then just change the y. So we have to increment the y every time. So instead of that just being 0, it's going to be track J in this case, right? Times track track height. And this will be J times track height plus track height, right? So it's going to be, if you think about it, track height will be 0. So you want the line to start at the top of the track and go to the bottom of the track. So, it'll be 0, starts at 0, and then, but the y2 needs to be at track height, right? So it can't be track height. So we're going to copy that over. And then we're going to put that in parentheses, just so the order of operations is smooth. And then we're going to add. So it's going to be J plus times track height plus another track height, right? Because it's one track height away from that, away from this, right? That y1, y2 is one track height away from that. Okay, and then this is all in this for loop. So it's going to do the number of tracks times of these, but for each track, it's going to do the number of measure lines, number of measures of these. So see, instead of, can you imagine the amount of lines we'd have to write? We'd have to do whatever, 4 times 8, right? So instead of running line 24 times, this one little bit of code takes care of all that. Okay, so we have measure lines for each one. Now, maybe so it just doesn't look like this graph paper grid, maybe we'll just make them slightly shorter so they don't fill the track completely and it looks like just lines coming down. So that's easy enough done. We'll just have to change the two y coordinates to be, so remember plus is down, so we'll add whatever, a few pixels to the top and we'll subtract a few pixels from the bottom. So let's put those in parentheses so that it does that first, and then we'll just add plus, I don't know, maybe 10 or 20 pixels. Let's try 15 maybe. Okay, and then here as well we'll just minus 15, but since plus and minus is the same thing, it doesn't matter what order you do it in, just do that. So now the measure lines aren't going all the way connecting up and down. I could make it even smaller if you want. Just change that. Sure, why not? 20 and 20. Great. Okay. Great. So we're getting there. We got our, our measure markers in. And I'm even wondering if we need this initial one, but why don't we keep it for now? We'll just keep that there for now. Okay, now, just save that. So we got our beat grid going, and then our beat markers going now. So yeah, I did make a nice for loop here, and I'll just pop that in here in that one line format. So it's a little bit, because now we're going to do this multiple times. So this does kind of, pan this out for just like I did here, the lines, because even more exceptionally, we really need these because there's 16 of them per track. Yeah, but let's put this in more abstract terms so we can change. For example, if we want to change the grid, we can change the number of measures per track. So we can make those adjustments by changing one number. So let's variabilize, I guess, this one. So we need the number of beats in the track. That's 16. Okay. So, or we can do like the number of beats per measure. We can do that, and then we can times it by the number of measures in a track. What do we have already? Maybe. So we have a number of measures, and maybe we'll have a beats per measure. Why don't we do that, and then we'll calculate the number of the number of beats in a track. Yeah, I guess so. So let's go int beats per measure. Okay, and we're going to make that 4, kind of like a time signature, I guess. And then we'll just have another float, and this will be will it be a float? No, it won't. It'll be an int, and this will be beats per track. Okay, and we'll calculate that. So it's easy enough. Let's copy that. Beats per track. And the beats per track are going to equal the num and mes times the beats per measure. Okay, is that how I call it? Beats per measure? Yep. Okay, so that's the total beats per track. Copy that. So again, we're doing these beat markers, and we want to, variabilize, I guess, make these all variables. So remember, this is all the beat markers for one track. So we'll paste that in there. So beats per track. It's still 16 because we have 4 beats per measure, and we have 4 measures. So it's still 16. And then in this, we're going to adjust this here. So the x is going to be increment. We need the number of pixels per beat then. Okay, so we'll have to calculate that as well, I think. So we're going to make this pix per beat. Okay, And how do we calculate that pixels per beat? We declare it up there, and we calculate down here in setup. The pixels per beat is going to be, I guess, simply like the width, the number of pixels, divided by the number of beats. Should we do that? Yeah. Yeah, sure. Not. Do we have number of beats? So we need, well, the number of beats will simply be, well, we can make a separate variable and just do a calculation then. Let's go ahead and do that. We'll make it an int, num beats. Okay. And then calculate that here before this one, right? So num bts equals num measures times bts per measure. Oh, we already have that, beats per track. Oh, geez, okay. So we already have that, so we don't need another one. Sorry, I'm having Alzheimer's here. I just did it. And I put it next to the one, so number of beats and beats per track. Okay. Right, so beats per track is there already calculated, so it's going to be the width divided by the beats per track. Okay, and then we'll pop that into this for loop. So we're doing all that stuff so we can have things to calculate that. So if we know the number of pixels per beat, we'll do that I times that pixels per beat, right? Okay, so same thing. Let's just test it. 0 will be, x will be 0. 1, it'll be the pixels per beat, so move over that many pixels. So that seems to work out okay. And then this is the y location, which for now, we'll put, let's just leave it at 75 for now. And then this is just the size, the width and size. We can hard code that. That'll be just the size of the dot. Okay, and I think 8 was pretty good. I mean, it could be slightly smaller, I suppose, maybe. Should we try 6? Let's see what 6 looks like. Okay, so again, this is just beat markers for one track. Okay, pix per beat. BT, I guess, probably. Okay. There. And that kind of works out, but now it doesn't line up. And I remember there was an issue there with the rounding or something like that, the way I rounded it up. Okay. Okay, and so I think what we need to do then is sometimes the calculations are rounded at different areas. So if I just make these all floats, I'm going to be a bit hacky about this and just change all these into floats for now. I think maybe something like number of tracks or something doesn't need to be float, but let me just be sure of that. Just change all those floats. I'm not really doing any heavy calculations, so that might not be the most efficient, but it's okay. Yeah, and that looks better. That lines up better. So yeah, there's some rounding errors there. I'm sure if I just gave it a little bit of thought, I'd find it. But we'll just leave it at that for now. That's an easy solution. Okay, so that's for one track. Now we just have to do it for every track. So then again, we use the for loop with the j for int j equals 0. J is less than num tracks, and then j plus plus. Okay, and we'll pop that in there, and then we just have to fix up the way it calculates the y, right? So ellipse is x and then y. The y is going to be j times, I think it's just track height then, TRHT. I think just simply that. All right, but then we have to add half because we want it to be midline of the track, right? So j plus track height divided by 2. And then we'll just, all right, but then we have to, right, plus j times track height plus track height minus 2. That's right. Okay, divided by 2. So j times track height plus that, right? Does that make sense to you? Hopefully, we'll put those in parentheses, so order of operations. So in other words, you know, j times track height will move us to the top of the next track, and then we're going to add half of the track to bring us to the center of that track. Yeah. So if we test it, we say 0, so that becomes 0. 0 times track height is 0, and then it's track height divided to 2, which is, you know, half of the track height. I guess at 120, so it'll be 60 pixels down. And then the next time is 1. J times track height is, you know, 120. Bring us to the top of the next track, and then add half of that track's height. So bring us to the middle of that track. Okay, so these will end up in the middle. And there you go. So power of for loops. We gotta love those for loops. It just makes our work so much easier. All right. So we just continue in this vein, but for all these things, I suppose. Yeah, there's a fair bit more to do. So yeah, so yeah, we can just go through and change some things. I'm just trying to think of the best way to proceed. Well, let me do a few more things, and then maybe we'll start another video. So the cursor here is, it's going to get this index anyways. Remember, we're getting the location information from Super Collider, and we just simply make the line all the way down the whole canvas, which is easy enough. So CX is the index, the cursor X, I guess, and so it's, you know, X1, Y1, X2, which is fine. Y2 will just simply be height. So that's easy enough to do. And so it goes over the whole canvas. These highlighting things, I suppose we need to make now arrays of these things, these playtogs and rectogs. So yeah, let's go ahead and take care of a few of these things. So so we know if each of the tracks are recording. But actually, let me wait till the next video for that, maybe. So yeah, maybe we'll stop there. Basically, I've just introduced this idea of using these for loops to create multiple tracks, multiple items for each track, right? Because we just have to repeat it the number of track times. And I've made it so that you can just simply change a variable here, and unfortunately also have to change the size to make it different number of tracks, 16 or 24, whatever you want to do, and it'll just sort of calculate everything. Obviously, you have to adjust your track height because, you know, you're going to run out of screen real estate, so you can just do that. You know, if you wanted to modify it another way based on the number of tracks and it just shrinks each track down to fit in, that might be a better way to do. So then instead of calculating the total width, the total height here, you just do it in reverse. You'd have the total height and then calculate each track height. And you can do it that way. Maybe that would have been a smarter way to go. Either way, it's fine. And then I did, you know, a number of these calculations. I just made all these variables so that it would make some of these calculations a little easier to calculate how far to put the beat markers out and the measure markers out. All right. So the next time, I think we'll just tackle then these OSC things, how to send the multiple track information back to Super Collider, which we've done that half in the Super Collider part. But now we'll have to make some adjustments. And then maybe the video after that, it could be next video, we are going to have to think a little bit about the way we turn record on and off. But we'll get to that later. Okay, so I'll start that video there. Hopefully that works well for you. Good luck with that.